Very good morning to you all.
Good morning, madam.
Only 45. Calm, cool. ତମର ଆସିନା କାଇଁ ମୋର ତମର ତ କ୍ଲାସ୍ ହେଲା ଆଜି ମୋର ସରିଯାଇଛି ତ କ୍ଲାସ୍ ହବ। Fifty. I am audible? କଣ?
Yes, ma'am.
I am
Audible. Yes, ma'am.
Yes, ma'am.
ନେଟ୍ ପଳେଇଥିଲା ବୋଧେ ମଝିରେ। So okay. Last class what we discuss? You start today? Which
Up
article?
to type 3.
Huh?
4.4 completed, ma'am.
Yes?
4.4 completed, 4.7 will start.
We'll start 4.7 optimization. Okay. Okay. Coming to that. Tell me what is optimization? Tell me what is optimization?
What is optimization? What is optimum? Tell me. Optimum value. What do you think?
Not
Optimum value.
maximum or minimum.
Yes, it is your maximum or minimum value. So here we'll read about that optimum, the maximum and minimum value. So the business person, what he wants, a business person wants to minimize his cost and maximize the
Profit.
profit. And a traveler, what he wants, he or she, a traveler, what he wants? To minimize the transportation time. The screen is visible?
Yes, ma'am.
Yes, ma'am. No, ma'am.
No. It is not visible.
Yes, ma'am. Yes, ma'am.
Okay, so here we'll read about that for that maximization and minimization of the such problem, which is area, volume, profit for the maximization, and distance, time, cost for the minimization. We'll read here this type of problem. So here, to solve that problem, we need some steps. So write down the steps here. Steps in solving optimization problem. Steps in solving optimization problem. Write down. Step 1. Understand the problem. Step 1. Understand the problem. The first step is to read the, write down. The first step is to read the problem carefully until it is clearly understood. Ask yourself, what is the unknown? Ask yourself, what is the unknown? What are the given quantities? What are the given conditions? Again, I'm saying the first step is to read the problem carefully until it is clearly understood. Then ask yourself, what is the unknown? What are the given quantities? What are the given conditions? Second step, draw a diagram. Second step is your draw a diagram. Okay. In most problems, it is useful to draw a diagram and identify the given and required quantities on the diagram. Again, I am repeating this one. In most problems, it is useful to draw a diagram and identify the given and required quantities on the diagram. Step 3. Introduce notation. Introduce notation. Assign a symbol. Assign a symbol to the quantity that is to be maximized, maximized or minimized. Let's call it Q for now. Let's call it Q for now. Okay. Also select symbols A, B, C, X, Y, Z for other unknown quantities. For other unknown quantities, and label the diagram with these symbols. For example, you may use capital A for area, H for height, T for time. You may use T for time. Then 4. Express Q Q or F or H or T. Express Q in terms of some of the other symbols from step 3. It is 4. Then 5. If Q has been expressed as a function of more than one variable, in step 4, use the given information to find the relationships among these variables. Use the given information to find relationships among these variables. Then use these equation. Then use these equations to eliminate all but one of the variable in the expression for Q, then use the equations to eliminate all but one of the variable in the expression for Q. Thus, Q will be expressed as a function of one variable, say x. Function of one variable, say x, that is Q is equal to function of x. Write the domain of the function. Write the domain of the function. Then 6. Use the methods of section 4.1 and 4.3. Already you know how to find out the maximum and minimum value in section 4.1 to 4.3. So use the method of section 4.1 and 4.3 to find the absolute maximum or minimum value of f. To find the maximum, absolute maximum or minimum value of f. In particular, if the domain of f is a closed interval, then the closed interval method in section 4.1 can be used. In section 4.1 can be used. All of you have written all these 6 conditions.
Yes,
I'm asking you, all of you written?
Yes, ma'am.
Okay. Now we start problem. Write down question, example. First I'm doing one example, 1 to 2 I'll do. Then I'll go for your problems. Here. A farmer has 1200 meter of fencing. meter of fencing and wants to fence off a rectangular field that border a straight line. Rectangular field that a border borders a straight line. Straight river. Here it is river. Straight river.
ma'am, repeat
Yes.
the question, please.
Here it is I have written. I am writing here. A farmer has, only this portion I have not written. A farmer has.
Not visible, ma'am.
Huh?
I'm not visible till now. Anything.
Not visible. Okay. I'm going to stop here now. Again, I'm doing it. Why it is not visible, that I don't know. Okay, I'm going. Okay. Now visible? Now it is visible?
Yes, ma'am.
In net, due to the net, that is. Okay. A farmer has 1200 meter of fencing and wants to fence up a rectangular field that border a straight river. Okay. He needs to fence along the river. He needs no fence along the river. No fence along the river. What are the dimension? What are the dimension of the field that has largest area? All of you have written this question, then we'll discuss. Over? That has largest
No,
area.
ma'am.
Quick. Over? I'm going to erase. I'm going to erase. I'm audible?
Yes, ma'am.
Okay. So, the question is asking, what is the question asking? Tell me first. What do we want to find out?
Dimensions L and B.
No, the field that has largest area.
Largest area. We have to find out how we fence that field, we get the largest area. Is not it? Okay. So what is given condition? What is given condition?
1200 meter of fencing.
Yes, 1200 meter of fencing a farmer has. He wants to fence the rectangular field which has the border is your river. Isn't it? So if I do like this, the border is our river. It is your 100. It is your 100 to fence. 100 meter, it is 100 meter, and it is what is left? It is 1000 meter. So what is the area of this rectangular field? What is the area?
1 lakh meter.
Yes. meters square. If you will fence like this, it is the river. 400, 400, 400. It is 400, it is 400, it is 400. What is the area? What is the
160,000.
area? Okay. If you will fence, it is your major basic. 500, 500, then it is left 200. It is our not necessary to fence this. What is the area? What is the area? What is the area? It is 200. What is the area?
Oh no.
1 lakh.
Yes. Meters square. So which one is more? This one? So like this, in which way he will fence that he will get the maximum area? We don't know. We have to find out. So what we'll do here? It is our river. We put this side as x, this side as x, and this side as y. Okay? You put this side, your depth is x, and your width is y. So what is the area here?
XY.
Area is, huh? XY meters. All of it clear? So both are unknown. Substitute the value
Yes,
is
ma'am.
unknown here, like A, B, C. It is written X, Y, Z. So I substitute here. It is X, X, because it is rectangular pit. So it is X, X, and it is Y. I substitute like this. So here the 1200 meter it is given to you. The farmer has fencing. So 1200 meter is equal to, he fenced this rectangular field. So 1200, what you write down? 1200 meter. It is no need to fence the river.
2x plus y.
Very good. It is 2x plus y. All of it clear? All of it clear?
Yes, ma'am.
The maximum value of x is how much? Tell me. Here, the maximum value is how much? Is it more than 600?
No, ma'am.
No.
No, ma'am.
So x is less than equal to 600. We can say.
Yes, ma'am.
And the minimum value, it is, I can write down, it is 0 is less than, you cannot say that it is 0. If you say 0, then we cannot fence the river. So you cannot say it is 0. So 0 is the x lies in between these two domain. Clear to all of you? It is clear or not? If you take the value of x is equal to 600, more than 600, not possible, because it is the value is the farmer have the fencing, it is 1200 meter. Isn't that it? So if you take x is equal to 0, then we'll get the area is equal to 0. Isn't that it?
Ma'am, then it must be less than.
Yes, I'm going to that part.
No, ma'am. X should be less than 600, not x would be less
Yes,
than
I'm
equal
going to that point
Yes,
now.
ma'am.
Okay. I can write down like this. This line.
Yes,
Clear to
ma'am.
all of you?
Yes, ma'am.
Clear to all of you? Okay.
Yes, ma'am.
So what is the condition is given here? 1200 is equal to 2x plus y. So what we'll do here, we convert this a to the one variable, isn't it? That is written on your steps. I think it is step 4 or 5. Express q as in one variable. It is in which? Yes, one variable, it is in 5. Step 5. If you are writing, go to the step 5. Q, I am writing q as a. You can change it. I've written it is, you can change a area for h as height and t for time. Okay. So it is, we can change this now as a function of one variable. So I can write down this implies y is equal to 1200 minus 2x. I can write down from here, from the constraint, I'm getting y is equal to 1200 minus 2x or not? Is that clear?
Yes, ma'am.
Okay, I can put here. So I'll get the value a is equal to x into 1200 minus 2x. Now, to find out the maximum and minimum value, what we are doing? We have to find out the critical point, value of x, by using that a dash. Here we get the ax is equal to this value. So a dash x, it is a function of x. Area is our function of x or not? Only.
Yes, ma'am. Yes, ma'am.
Okay. So now I find out a dash x. What you get? 1200 minus 2x. Then plus x into, that is, what you get? Minus 2. Derivative of this is your minus 2. So it is 4x. So this implies the value of x is equal to how much? Tell me. The value of x is equal to how much?
300.
300. Okay. Now a double dash x. What you are getting? Minus 4. It is minus 4. This is 0. A double, the second derivative test for the maxima and minima. A double dash x is equal to minus 4 or not? It is your 1200 minus 4x. So it is, what you write down? A double dash x is equal to minus 4. No response from your side.
Yes, ma'am.
Okay. So it is less than 0. If it is less than 0, at the value x is equal to 3 and we have the area is maximum or minimum?
Maximum.
Maximum.
So now the area at x is equal to, 300, area is, area of the field is maximum. Okay. So what is the value of y? What is the value of y?
600.
600.
600. Okay. So all of you clear?
Yes, ma'am.
300 meter depth and it is 600 meter width. Clear to all of you?
Yes, ma'am.
Next, come to the next step is example. Before that, write down some definition. Before that, write down definition. First derivative test for absolute extreme value. First derivative test for absolute extreme values. I'm going to erase now this page. I'm going to erase this page. Suppose that Suppose that C is a critical number, small c. Small c is a critical number of a continuous function f,
Ma'am, repeat.
Suppose that C is a critical number of a continuous function f defined on an interval A is equal if first bit if this x greater than 0 for all, this is the symbol for all x is less than c, and if this x less than 0 for all x is greater than c, then fc is the function of c is the absolute maximum value of f. Value of f.
Yes, ma'am.
B. Bit B. If, just opposite, if dash x is less than 0, for all x is less than c, it is the same, these two are same, and if dash x is greater than 0, for all x is greater than c, then f dash c is the absolute minimum value of f. Minimum value of f. All of you have written these two. It is over. Now come to the example. Find the point on the parabola. Find the point on the parabola y square is equal to 2x that is closest to the point, closest means absolute minimum value, to the point 1, 4. The question is asking find the point, not find out the value, distance value. Closest to the point 1, 4. Okay? So, what he wants here? Tell me. What we want to find out here? I'm audible?
Yes, ma'am.
Tell me.
We have to
What we
find
want
the,
to find out? Huh?
we have to find the point which is closest to the point 1, 4, and that point
Yes.
lies on.
Our parabola is, draw the figure here. If possible, you draw the figure. So y square is equal to 2x. It is our parabola. I say that. So where it lies? It lies here, or it lies here, or it lies here, or it lies here? Here, where?
First and
First.
second quadrant.
Yes. So my parabola is like this. Isn't it?
Yes, ma'am.
Okay. It is a point here, which is our xy on that parabola. And the value 1, 4. Say it is 1, 2, 3, 4. So 1, 4, let it be here, this point. So what do you want to find out? We want to find out the distance, d. Minimum distance, absolute minimum distance, we want to find out. Isn't it?
Yes, ma'am.
Distance, d is equal to how much? Tell me. All of you know the formula of distance. Tell me. It is given point xy, it is given point 1, 4. What is the formula?
X2 minus X1 whole square plus Y2 minus Y1 whole square whole root over.
X minus 1 whole square, I can write down, plus y minus 4 whole square. I can write down like this or not?
Yes, ma'am.
Okay. So this is equal to, I can write down now here how it is, though it is root over of this value, it is not so easy to solve, to how we solve. Here we write down it is, this implies d square is equal to x minus 1 whole square plus y minus 4 whole square, that we consider as the function of x. Then we find out the value of xy. Okay? This is our fx. We consider it is. So it is here. What is the condition given? It is maximum, it is y square is equal to 2x. It is given to us. So the value of x is equal to, the condition it is given as y square is equal to 2x. So we have to convert this. It is the having the two variable here. You see, having two variable, we have to convert it as the, sorry, don't write down. It is the function of x here. Now convert it as the function of one variable. Then you write down it is the function of x. So d square is equal to, what you write down at the place of x is equal to y square by 2 minus 1 whole square plus y minus 4 whole square. So we write down it is the function of y. Clear to all of you? Clear?
Yes, ma'am.
Okay. So now convert it is in the form function of y. I am writing here. So it is f dash y. Two into y square by 2 minus 1. Then derivative of this is how much here it is? It is 2y. So into y. Clear? Clear or not? Derivative of this is 2y by 2. So it is cancelled out 2. So we get only y. And it is 0. Then plus 2 into y minus 4. Equal to 0. Simplify. Find out your equation. What is the equation you get here? You simplify and find out your equation. Do it yourself. Then I'll explain. Tell me the equation first. After simplifying.
YQ equals to 8.
So we get YQ equal to 8. All of you got it? All of you got it? YQ is equal to 8? You are doing or not? I'm asking you.
Ma'am, doing. Wait, ma'am.
Yes, ma'am, doing.
Doing, wait. Okay. Over.
Yes, ma'am. Done.
So what is the value of y?
2.
2.
2.
Two,
Okay.
two.
The value of y is equal to 2. Now come to that definition, that first derivative test of absolute extreme values. These two. Come to this two definition. What we are getting, f dash y is equal to 0, we are getting y is equal to 0. So f dash 2, f dash 2, what we are getting, it is less than 0 or greater than 0. If y is less than 2, f dash y is greater than 0 or less than 0, what is written here? If y is less than 2. Tell me. Less than 2. We are getting our equation. I am writing here y cube minus 8 equal to 0. It is less than 2 means we are getting it is less than or it is greater than.
It is less than.
Yes, very good. It is less than 0. Okay. Then again, f dash y is again less than or greater than if y is greater than 2 according to this condition. First I solve by using this condition, then according to this condition. Greater than 2. Greater than 2.
Greater than 0.
It is greater than 0. So which condition satisfy? This one? These two satisfy?
Yes,
So
ma'am.
what do we get here? It is the absolute minimum value. At C, I'll get absolute minimum value.
Yes, ma'am.
Is not it? So you can write down your answer here according to the first derivative test. I'm getting the value f dash y is less than 0 when y is less than 2, and f dash y is greater than 0 when y is greater
Ma'am,
than
can
0.
you repeat this one?
Which one I'll repeat? This one? Which one? Which portion I'll repeat? Tell me.
Ma'am,
Ma'am?
definition. Yes.
Yes, definition. Okay.
Ma'am,
We got the value.
Ma'am, how
Huh?
did you solve using the definition?
Okay, how did you solve? We got this equation. It is here. I got that by putting it is equal to 0, then I am getting it is your value yq is minus 8 equal to 0. I am getting here. What you get for the value f dash y? We get yq minus 8 or not? We get that value? That is our, this is without f dash y or not?
Yes, ma'am.
Okay. Now your definition, what is the definition say? When y is less than 2, means you put your value as 1.5 or 1.9, you consider. It is less than 2, not equal to I'm writing here. So it is y is less than 2. What we consider the value of y here? Let it be 1.9. So you have calculated, find out the value 1.89 whole cube is how much? Find out the value of y is 1.9. Q minus 8. You are getting your value negative or positive.
Ma'am, can you repeat again? I'm facing some network issues, so I'm not able to follow.
Here your definition is this two.
Ma'am,
Yes, here I got this
yes,
value. Okay. I got it is yq minus 8 is equal to f dash y. I got from here.
yes, ma'am.
There. Okay. So now
Yes,
I'm
ma'am.
saying to you, when y is less than 2, what you are getting about f dash y? It is greater than 0 or less than 0? Less than 2, you may choose your y is equal to 1.9. It is less than 2? It is less than 2 or not?
Yes,
Wait.
ma'am.
So it is 1.9 whole cube minus 8. You are getting your value as a negative or positive.
Okay.
You have calculator, find out the value of 1.9 cube. Find out your value. How much you
Yes,
are
ma'am,
getting?
it's minus 1.141. Minus 1.141.
Minus 1.141.
141.
You are getting the negative. F dash y is negative. I am getting here. It is clear. Less than
Yes,
0.
ma'am.
Okay. If I will take greater than 2, according to our definition, these two are same for these two steps. So it is according to the definition, if I consider y is greater than 2. So what you will get here, it is the value. F dash y greater than 2, you may consider 2.1. So 2.1 cube minus 8. It is positive or negative? My aim is to know the positive or negative. I don't want to know the value. It is coming positive or negative?
Positive.
Positive. So I'm getting here, it is positive here, this one. I've written here. Clear? So which condition satisfy
Yes, ma'am.
here among these two? Which condition satisfy? Among these two definitions, which one it satisfy? A or B? Tell me.
B.
B. What is
B.
it then? Then f dash c is the absolute minimum value of f. It is, sorry, f dash c is not, it is fc. Sorry, I have written f dash c. Then fc is the absolute minimum value of f. All of check it. It is, don't write down f dash c. We are getting the critical point here, but the value is functional value. So fc is the absolute minimum value of f. Clear? It is written. The closest means it is the minimum value. Closest, the question is asking about the closest.
Yes, ma'am.
It is the minimum value. So
Yes,
where
ma'am.
for what value of x we are getting the value minimum value?
Two.
X is equal to 2. So question is asking at what point? The question is asking find the point on the parabola, means you know the x is equal to 2. What is the value of y?
2.
Y is equal to y is equal to
Y
x is,
comma x is equal to 2.
y square is equal to 4. Y is equal to also 2. Y is also 2. It is in the first quadrant. Y is the value is how much here it is?
2.
Y square is equal to 4. Y is equal to how much? 2.
2.
So at which point? The point is our 2, 2. The point is our 2, 2 or not?
Yes, ma'am.
Okay. If the question it is asking, it may asking to you find out the value of. So what will do? You have to find out the value here. Don't do here. Just to solve our problem, I am using d square. You find out the value of d, put the value xy here and find out the value of d. Clear? All of you clear this question?
Yes,
Or
ma'am.
Yes, ma'am.
okay. So now this set article you have lesson plan. All of you have lesson plan?
Yes, ma'am.
So what is your classwork problem? What is your classwork problem? Tell me the number of classwork problem. I have to see. Huh? No one have a lesson plan. I will give him
Ma'am, 5, 19 and 27.
5, 19 and 27. So today write down the question number 5. It is 2 minutes only left. So okay, we'll discuss in the next class. First you write down the question. Question number 5. Tomorrow you have 2 period class. We'll discuss this question and we'll start 4.8. You may get question up to 4.8 in midsem. I think your midsem may be after 8. Second week, I don't know, it may be 8 or after that. So what is the...
Can we do?
Yes.
Can we do this question with slow form? That if this is the point which is closest to the 1,4, then it should be lie on the tangent. Like that.
It should lie on the tangent. Yes, it should be lie on the tangent. Yes, okay.
I have done by this method. I got the same answer.
But here our aim is to solve by using our optimization method.
Okay, ma'am.
Okay. Your answer is so many methods in mathematics. But what we are reading now?
We should apply optimization to the question.
To the point. It is okay. So write down the question number 5. What is the maximum vertical distance? What is the maximum vertical distance between the line y is equal to x plus 2 and the parabola y is equal to x square for -1 less than equal to x is less than equal to 2. The domain is given to you. Under that interval, what is the maximum vertical distance? So all of you clear what we want to find out? Maximum vertical distance we want to find out here. So it is your y is equal to this value and y is equal to the points are here it is x plus 2 and here it is x square on the parabola. So according to that you write down D, then we'll solve in the next class. It is already time. Okay, we'll solve this problem in the next class and other problems also. I'm going to, teacher may be waiting. I'm going to stop sharing.
Okay, good morning.
Good morning, sir.